All right, welcome. Today we're going to talk about inverse trigonometric functions. Okay, so before I start with inverse trigonometric functions, let's just start talking generally about inverse functions. Okay, so let's talk about the square root of x, which is one of my favorite functions to talk about. Why? Because it's the inverse of my favorite function to talk about. This is equivalent to saying, okay, let me be careful here because I screw it up a lot. X equals y squared and y is greater than or equal to 0. Okay. Why do I do this? Why do I make that distinction, or why make that why do I make this restriction? Well, when we graph this, if I'm graphing x equals y squared, okay, then I need to graph that just the top part. Okay, this part is thrown away. Okay, why? Because we want our inverse function to pass this vertical line test, right? Okay, so we throw it away so that we have an inverse, a valid function as an inverse. Okay, so now we're going to take the same idea and we're going to think about it as we're doing our next example. So we're going to start with the inverse sine. Okay, so let me y equals sine inverse of x, okay, is equivalent to x equals sine of y, okay, and we're going to take y between pi over 2 and negative pi over 2, okay? So let's go ahead first, let's graph it from just the regular graph, and then I'm going to show you how I think about it using the unit circle, okay? So let's start with the graph of y equals sine of x. Y equals sine of x, and I'm actually going to start it here at negative pi over 2. I'm not really going to start it there, I'm actually just going to extend it. Okay, let me circle all this, put it in. Okay, so remember, sine starts at its middle and goes up. So that means our sine graph here is going to look like so. Let me extend this here. Okay, so that's the sine graph. Now, when I do the inverse sine, I have to make sure that my original function passes the horizontal line test, or my mu inverse function passes the vertical line test. So I'm going to cut it off here. Okay, and cut it off here. Because my sine would continue going here, but I just want this region so that I can say, you know what, it passes the horizontal line test. Okay, so now my mu inverse function, which I don't need to graph that again. So now this point down here is negative pi over 2, negative 1. So in essence, it's going to change to now being the x coordinate. Let me write it down. negative pi over 2, negative 1 goes to negative 1, negative pi over 2. Okay, so negative 1, negative pi over 2, let's say that's somewhere around, just check something real quick. So pi over 2 is about 1.5, so it should be, let's say, right around here. Okay, that's negative 1, negative pi over 2. This point here, that's 0, 0. 0, 0 should, of course, go to 0, 0. Just replacing, changing the position of x and y. And finally, this point here, which is pi over 2, 1, should go to, that's right, 1 comma pi over 2. So that'll go, let's see, right about here. Okay, so something like this. Okay, so this blue, let me make that a little thicker. Now it's just going to be obnoxiously thick. Oh. And not so bad. Okay, that blue, that's what the inverse sine looks like. Okay, let me give myself, no, I got enough space. So now I'm going to show you how I think about it. Okay, so this is all, that's all well and good, but this is how I actually think about it in practice. I actually go to the unit circle. Make that a little smaller again. Okay, I go to the unit circle. I draw only the right half of it. Draw that a little better and a little bigger. Okay, so I draw the right half of it. Sorry, that's just too ugly for me to accept. That's about right. Okay, and then I think about the angles that are on this side of the unit circle. Okay, so for example, sine inverse of 1/2, since 1/2 is about here, is going to be pi over 6. And I throw out this 5 pi over 6. Okay, now there's nothing really that stops me from doing that other than that's how we do it. Okay, so if you wanted to develop mathematics completely with, taking the sine inverse on this side, by all means go ahead. There's nothing logically stopping you from doing that other than you'd be wasting your time, okay, on something that's already been done before. Okay, all right, we'll come back and do some cosine problems.